It's been called liquid gold, and not just for its pale amber hue. Blood plasma, the cell-free component of blood, is now taking center stage in the high-stakes world of anti-aging research. Once dismissed as a passive medium for floating red and white cells, plasma is increasingly viewed as a dynamic, information-rich fluid, carrying thousands of signaling molecules that can either accelerate aging or, under the right conditions, help reverse it. And that's not science fiction. It's science with needles, centrifuges, and a rapidly growing body of clinical intrigue. The plasma hype began with a rather creepy-sounding but very real experimental setup called heterochronic parabiosis, in which the circulatory systems of a young and an old mouse are surgically joined. The results? The older mouse experiences improved tissue regeneration, enhanced cognition, and even rejuvenation of heart and muscle. The younger mouse, meanwhile, begins to show signs of premature aging. Something in the young blood, and something else in the old blood, is clearly at play. This led researchers to ask, could plasma itself be the key? Not the blood cells, but the soluble factors in plasma, cytokines, hormones, growth factors, microRNAs, metabolites, exosomes, collectively forming a kind of molecular fingerprint of age. These elements don't just reflect the body's state, they instruct it. When plasma is filtered, concentrated, or exchanged, the molecular messages change, and so, possibly, does the rate of aging. Several strategies have emerged from this science fiction turned reality. Young plasma transfusions, one of the more direct and controversial ideas, involves taking plasma from young donors and infusing it into older individuals. Animal studies have shown significant improvements in neurogenesis, memory performance, and muscle regeneration in aged mice receiving young plasma. In humans, early-stage trials, like those led by startup Alcest, have explored the effects of young donor plasma in Alzheimer's patients. While results have been modest so far, the therapy appears safe and biologically active, particularly in modulating inflammatory and neurodegenerative pathways. Plasma exchange, therapeutic apheresis. Instead of adding young plasma, what if we simply remove the old stuff? This concept, sometimes described as diluting the old, involves filtering out pro-aging factors and replacing them with saline and albumin. A notable pilot study called TRAP, Therapeutic Plasma Exchange, showed that plasma exchange in older adults led to shifts in inflammatory markers, improved epigenetic age scores, and in some cases, better physical performance. The idea is simple. Old plasma contains harmful byproducts, advanced glycation end products, senescence-associated secretory proteins, autoantibodies that gum up tissue repair. Flush those out, and the body may recalibrate toward youth. Enriched or engineered plasma. This is the sci-fi version that may soon become biotech reality. Researchers are working on creating designer plasma products, plasma enriched with beneficial factors like GDF11, a protein linked to youthful neurogenesis, Clotho or BDNF, while removing harmful elements. Think of it as precision plasma therapy, a blood-based version of a targeted drug, but capable of reprogramming multiple organ systems at once. Exosome-based therapies. Plasma is loaded with extracellular vesicles, including exosomes, tiny lipid bubbles that carry microRNAs and proteins capable of regulating gene expression in distant cells. These exosomes can cross the blood-brain barrier and may be responsible for some of plasma's rejuvenating effects. Some labs are now isolating youthful exosomes or engineering them to deliver regenerative signals specifically to aging tissues, including the brain. Critically, what all these approaches share is a shift away from the magic bullet model of medicine towards systemic modulation, tweaking the biochemical soup that bathes every organ, rather than treating each symptom in isolation. Aging, in this view, is not just a breakdown of tissues but a miscommunication in the bloodstream. The signals become garbled, inflammatory, confused. Plasma therapy aims to clear the static. Of course, there are caveats. Plasma therapies are still in their infancy. Many of the most impressive findings are in animals, and human trials are small, early stage, and not yet definitive. There are also ethical and logistical concerns: plasma sourcing, immune compatibility, cost, and accessibility. And as with any anti-aging intervention, the effects may be temporary unless combined with lifestyle or molecular interventions that sustain the benefits. Still, the fact that one fluid, blood plasma, could contain both the instructions for decay and the keys to rejuvenation is a radical and compelling idea. It suggests that age might be less about time itself and more about chemical signals, tissue crosstalk, and the body's ability to interpret its own messages. And if we can tune those messages either by dilution, enrichment, or targeted infusion, then perhaps we can also retune the body for a longer, healthier life. In short, plasma isn't just a liquid, it's a language, one we're just beginning to decipher. And as the science matures, the notion of a blood-based anti-aging therapy might no longer seem like speculative alchemy, but a legitimate biomedical frontier where aging becomes just another variable, fluid, dynamic, and maybe, one day, reversible.